everyone. So today I want to talk about the analysis of logarithmic functions. So the logarithmic function that I will look at today, or the log function, is y equals log base 10 of x. So this is what I have here, graphed to the right. So the parent function that we will observe, f of x's function, is y equals log base b of x. And then in this instance, our base b is 10. Okay, now let's look at our domain. So for our domain for a log function, our domain is all the set of positive real numbers. So remember that log of 0 is undefined. So we would start with 0, not including 0, and go all the way to positive infinity. So this is our domain in interval notation. Alright, next thing we have, alright, let me put the arrow, is our range. So what is the range of our function here? The range of our log function, so if we look at our y-axis, observe it, you see we've got all real numbers. So I can have negative numbers, I can have positive numbers. So this is the set of all real numbers. Everything from negative infinity to positive infinity, and sometimes we just write or the set of all real numbers. We can write it with the R notation. So here's our range. So going back to the domain, we also have an asymptote here in the log function. The asymptote here is a vertical asymptote. Alright, so I'll put that in parentheses, vertical. And as we noted before, it doesn't quite touch x equals 0. Right, because if we have an x value, it creates a vertical asymptote. So let me go ahead and draw. So here is our, right here, our y-axis is not included. Alright, so it's this whole thing right here. Alright. Doesn't quite touch x equals 0. So that's our asymptote at x equals 0, that vertical line. Then we have, so the type of graph that we're looking at, the type of graph we have is, this is a continuous function. It's continuous on all the points. All those points in our domain are included. So this is continuous. And for every point in our graph, for every domain, we have a range value. So this is 1 to 1. Alright, or in notation, we write it as 1 to 1. Alright, so this log instance that we have, our log base of 10, this is if our b value is greater than 1. Right? And in this instance, our b is equal to 10. Now let's look at an example where our b is a fraction. So let's look at an instance where we have b is in between, wow, I'm writing colors. Okay. Where we have our b is in between 0 and 1. Okay, and then we have, so the graph I have here is log base 1/2 of x, right? So this time, so here's our analysis. This time our parent function is still, all right, that log base b of x is equal to y. But this time we have log of base 1/2. Now what makes this different with our b when it was equal to 10 in the first instance that we looked at? So we have here, again, our domain. Let's start with our domain. Our x values. Our x values again span from 0 to infinity, not including 0 again. So it's the same thing with the log base of b with when it was equal to 10. Right? So our domain not including 0 goes all the way to infinity. Right? Now our range, let's see our range values. Again, our range values, if we look at our y-axis, right, our graph includes all the values from our y-axis, so all the y values are included. So this is the set of all real numbers. These squigglies are the brackets for set notation. All right, real numbers, or if you choose to write it in interval notation, this is from negative infinity to positive infinity. And again, our asymptote, it's the same as the log base 10 one when our b was greater than 1. We still have a vertical asymptote. So at our graph, if you see here on the right, it never quite touches our x-axis when it's equal to, or our y-axis, sorry, when it's equal to, so when x is equal to 0. So this is the vertical, and again, when x is equal to 0. So that's our asymptote. Then what else do we have? We have what type of graph this is. So our type of graph, we've got that this is also continuous on all the points. So all points are included. This is continuous. And we can also say that this is for every x, I have a y value. So this is a one-to-one function. All right, except the difference here, this has more of a visual difference. With our b in between 0 and 1, we have it going into decay, all right, or it's a decreasing function. Whereas if I went back up and I observed my log base of 10 function, this is an increasing function. All right, so this would be the difference between the two log values. I'll come back down here so you can see it.